Video on circles. We'll be looking at circles that touch internally and circles that touch externally. This is a sketch of two circles that touch internally, so one circle is inside the other and they meet at one point. And this sketch shows two circles that touch externally, and again they just meet at one point. In this video we'll be testing circles to see if they do one of these two options. And to help us make the decision, there's a couple of formulae that we can use. For circles that touch internally, we'll be using the formula d equals r1 minus r2. In this case, d is the distance between the centres of the circles. The distance between the centres of two circles that touch internally is equal to the full radius of the larger circle minus the radius of the smaller circle. For circles that touch externally, the formula is d equals r1 plus r2. This means that the distance between the centres of the two circles is equal to the radius of the two circles added together. There's a few other formulae that we'll need to be aware of in these type of questions. First of all, there's just the regular distance formula from the coordinate geometry of the line chapter. Don't forget that this formula can be found on page 18 of the log tables. And we also need to know that for a circle within the form x squared plus y squared plus 2gx plus 2fy plus c equals 0, that the centre is minus g minus f, and that the radius is the square root of g squared plus f squared minus c. And these also can be found in the log tables on page 19. So our example is to show that the circles x squared plus y squared minus 4x minus 6y minus 51 equals 0 and x squared plus y squared minus 12x minus 12y plus 63 equals 0 touch internally. The first thing that I'll need to do is get the centres and radii of the two circles. So I'm going to write in the general form of the equation. And for clarity, I'm going to label the circles C1 for circle 1 and C2 for circle 2. Let's work on circle 1 first. So I'm going to find G, F and C by matching up the terms from the general form and the equation. So I've got 2G is minus 4, 2F is minus 6 and C is minus 51. And now I'll just get G and F. And now that I have G, F and C, I can make the centre and the radius. And we can see the formulae up here for centre and radius. So to make the centre, I just need to change the signs of G and F. That's 2, 3. And I'll fill in the radius formula. Just bear in mind that it's a minus c at the end of the formula, and since c itself is negative, I should have a plus here at the end. And the radius comes out as 8. And since I'm looking at circle 1, I'm going to call this radius 1, so r1 equals 8. Now I'll do the same for circle 2. So again, I'll match up the terms to find g, f and c. So I've got my values for 2g, 2f and c, and it's easy to find g and f. So I can get the centre and radius now of the circle 2. Centre is really simple, just change the signs of G and F. So the radius this time is 3 and I'm going to call it R2. That's radius 2 because I'm talking about the second circle. So now that I have the centres and the radii, I'm going to be able to refer back to my earlier formula at the start of the video to figure out if these circles do in fact touch internally. And just to remind ourselves how that looks, these are two circles that touch internally, and the formula is that the distance between the centres should be the radius of the larger circle minus the radius of the smaller circle. So first of all, I'll calculate d, and d will be the distance between the two centres, and I'll use the distance formula for this. So I'll fill into that formula, and it might be helpful at this point to label your points x1, y1 and x2, y2. And my formula gets filled in like this. And the result for the distance between the centres is 5. Next, I'll check what r1 minus r2 is, and that's just 8 minus 3 using these two values here. And again, that works out as 5. So let's draw our conclusion. We can say this implies that the distance between the centres equals to r1 minus r2, and so the circles touch internally. Here's one to do yourself. So do these two circles, x squared plus y squared minus 8x minus 4y plus 11 equals 0, and x squared plus y squared minus 10x minus 4y plus 25 equals 0, touch internally. Pause the video here, give this a shot yourself, and then play and see if you're correct. So I've started by calling the two circles C1 and C2. I'm going to compare these circles to the general form of the equation of the circle to find g, f and c. Looking at circle 1 first of all, 2g equals minus 8, 2f equals minus 4 and c equals 11. So now I've got g, f and c. And for the centre, I'll use minus g minus f, so just change the signs of g and f. So for circle 1 it's 4, 2. And I'll substitute into the radius formula to get a radius of 3, which I'll call r1. Next we look at circle 2. And we'll note the values of 2g, 2f and c. So just dividing by 2 to get g and f, so they're minus 5 and minus 2, and c is 25, and now I can use these to get the centre and radius. So in this case the centre is 5, 2, So we'll fill that formula in then for R, and R2 comes out as 2. So I want to check if these two circles touch internally. So the formula that I'm using is D equals R1 minus R2. And just to note that I've labelled these two circles, circle 1 and circle 2, arbitrarily. What that means is that either of these could be circle 1 and either of these could be circle 2. So I'm not really tied to this being R1 and this being R2. They can swap around if needs be. Generally, when working out the formula, R1 will always be the larger radius. So now I can find the distance between the two centres. And again, that's using the distance formula from the log tables on page 18. And I'm applying it to these 2 points. Fill the formula in, and the distance between the centres is 1. I'll subtract the radii, and I get 1 for this also. So this shows that the distance between the centres is equal to the radii subtracted, and so the circles touch internally. In the next video, we look at circles that touch externally.